Hello everyone, this is your computer teacher Madan Pandey, and today we are going to discuss about Armstrong number. So what is an Armstrong number? So let's get started with the definition. An Armstrong number is an integer such that the sum of the cubes of its digits is equal to the number itself. So we have examples like 153, 371, these are Armstrong number. So let me show you the mathematical demonstration. What is an Armstrong number? So as discussed, I said that 153 is an Armstrong number. So we have theory. Let me show you the demonstration. 153. So in order to become the number Armstrong, the cube. So for example, 1 cube plus 5 cube plus 3 cube must be equals to 153. So let me show you. This is 153. So this number is an Armstrong number. So if it won't be, then this number would not have been an Armstrong number. So let us write a C program that any given number, it will find that any given number is Armstrong or not. So let's get started with the C compiler. So I have a skeleton framework already ready here. So I'll get started. So let me declare a few variables. So don't worry, this is the way you will get started in an examination also. So in the start, I do not know how much variable, what type of variable I need to declare. So I just know that I need a single variable to hold and value of a number. So I'll only declare none. So you also do the same way as I did. So you just put an comma and let it be, and we'll append the remaining variables right here. So I'm not appending semicolon at the end. At the end of this program, I'll be appending semicolon here. So int num, why num? So I need a number to check, or I need a number. So I'll just add a message that enter any number. This message would be to prompt to the user to enter any number. So I'll use another function to hold this number. The syntax is like %d for integer, and I'll be using ampersand of num. Num, remember, num is the variable we declared earlier. So scanf num is the number variable. So what I need to do now? So my logic is that I need to separate individual digits and make a cube of in that digit and sum with those individual cubes. So how I do is that I just start with an while loop while num is greater than 0. I am continuing with this logic. So first I need to separate bit. So to separate a bit, it's very simple. I will divide, or rather than divide, I'll say modulo divide with 10. So this will get me the separated number. So the number has been separated, it's okay, but I need to store it somewhere in some variable. So I will append a new variable. So that is remainder. As a remainder, I named it R. So I will store this thing in R. So R is the remainder, that is the last bit, the separated bit, separated digit of the number. So second thing I need to do is I need to calculate the cubes. So to calculate a cube, I could use a power function, or I could use simply I would multiply this 3 times. So let's get it as simple as possible for the first time. I'll just multiply it 3 times. So this is how I'm getting the cube of an individual digit. So I need to store it somewhere. So for simplicity, I'll make for cube cub. I'm storing this in a variable cub. So this is the way you are going to write it in exam. You do not memorize it or by heart it. how many variables you are going to need. You just keep on adding. The moment you need a new variable, you just append it there. So this is the simplest way that you are going to write it down in exam. So uh, you now you have a cube of a digit. Now you what you will do is you add those cubes to the cubes of individual bits. So what my logic is, I will initiate the sum bit at 0, y0. I'm discussing is few moment later, and I'll write this statement like this: sum equals to sum plus cub. So why I'm doing like this? So initially, when I'm adding something to the first digit that I'm separating, that initial addition would be 0. So adding 0 won't make any difference to this bit. But recursively when or iteratively when the next time the loop occurs, definitely the sum is going to hold a new value, and this new value is going to be added to the new value of r. So let us we'll discuss this in detail so few moments later. So we have an loop conditional statement, and we have this is as an initialization statement, and now we'll have an decrement part over here, and I will write it like num equals to, so sorry, I'm a little bit slow at typing. Num equals to num divided by 10. So I'll just change this bit. Okay, 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 okay. Now I'm done. Okay, this is the most logic part. But knowingly, I need to compare this sum bit. Sum is remember the sum is the actual digit which is going to be uh, calculated as a result of the sum of individual cubes of that digit. So I need to compare this individual bit with this original number. So but I'm changing this original number. So when the loop is terminated, the num is going to be uh, not greater than 0. It will be and zero number. So I need to copy this number. So I need to copy number to say variable n equals to num. Why I'm doing this? So I'm storing it. So I need to declare the variable n. So again, n is an integer type. So I'll declare it over here. So what I'll do is I'll make a comparison with an operator double equals to. If n is equals to sum, remember sum is our final number, which is is uh, the result of sum of individual cubes of individual digits. So I'll make a comparison with this. If n equals double equals to sum, the number is an Armstrong number. So I'll make an declarative statement printf backslash n. So the given number, or rather than this, I'll write the %d is an Armstrong number. So comma, but %d n is an Armstrong number, or else if this is not the case, then we're sorry to say this number is not an Armstrong number. So if this is not the case, the %d is not an Armstrong number. So what is %d? That is n would be the %d. So this is it. The program is up to this. So I'll write my final semicolon here at the end. So this is the way I make my student think. So instead of memorizing how many variables you need, so Just uh, keep an declarative part, and when you finally end your program, you just append your semicolon here, over here. So this is the easiest way to think of. So let me save this program file and just save, and let me run it over here. So execute, compile, and run. Let us see if there are any compilation errors. So okay, fine. Enter any number. So let me give some fake numbers like 1 2 3 4, and check me that this is Armstrong number or not. So the 1 2 3 4 is not an Armstrong number. So let me run it again, and this time I'll enter 153, which we already checked that this is an Armstrong number. Okay, this is our output, and the 153 is an Armstrong number. So basically, by theoretical definition, again, to summing up the lecture, an Armstrong number is an integer. It is an integer number such that the sum of the cubes of its digits, individual digits like 1 cube plus 5 cube plus 3 cube, is equal to the original number itself, like the number is 153. If this so happens, then the number is Armstrong number. So that's all for now. If you like my videos, please do subscribe and hit the like button. I will be seeing you soon. Thank you for watching my videos. Thank you.